Okay, so just turning it around. Whoops, not that. Yeah, you can go to the bathroom if you want, but be quick because we're going to be going over these questions. I want to make sure that you're here for them, okay? So, all right, folks, like I said, we're going to go over this. I'm going to go over every single question, all right? Again, it's your choice if you want to tune me out, but I would say it's even more to your advantage here if you would make sure that you follow along, write down the little notes that I'm going to write down and stuff like that to help you remember, okay? Because it's going to be super helpful if you participate fully in this today, okay? So please, please, please take advantage of this, okay? So first of all, are there any major questions here from these dots, okay? Can you find mean, median, mode? Are you okay with identifying outliers and stuff? Can you do variance? That is, standard deviation, range, and interquartile range. You don't need to worry about residuals, so you can cross that one out. Okay? Can you talk about normal or skewed data or evenly distributed? Okay? Hope you can do that. Scatter plots, we'll talk about that here in a second. Box and whisker plots, hopefully you can do that too. Dot plots, we'll talk about that here in a second too. 68%, 95%, we'll do that here. Two-way frequency tables. Correlation, causation, we'll talk about that a little bit here too, but that's not going to be super important right now. And then a scattered plot, give the line of best fit, and don't worry about those residual values again. You can cross that part out. Okay. Oof. So here we go. All right, given the set of data, answer the following questions. What was the mean? So again, we're going to do stat, edit, enter data, okay, and then stat, calc, 1 var stats. Okay, so there are your little commands right there. Stat, edit, enter data, stat, calc, 1 var stats. Okay, so I'm going to do that right now. I already have this data in. Okay, and then the mean, which is x bar there, it's equal to 65.7. Okay, what is the median? To find the median, how do I find the median here? What do I need to do? Scroll down and go to MED 65. Okay. Are there any outliers? Outliers, right. Outliers are numbers that are too big or small. If you want to write that little note to yourself, too big or small there, okay? And yes, we do. We have 120, okay? Now, some people might look at that and say that 34 is an outlier. I could see 34 potentially being an outlier, maybe, but definitely 120, right? Definitely 120, okay? But I might even give you 34 there, okay?
There's also a 39.
And 39? Okay, since 39, well, then maybe more than the 120 then, so I guess.
Just only 120.
I'd say just the 120 then, yeah. Okay, but if you said 34, I probably wouldn't, yeah. Outliers, if they're just too big or too small for your set of data. There is a way to calculate it. We're not going to worry about that, okay? Just if it's too big or too small. Number 4, do outliers have a greater effect on the median or the mean? Mean. Okay, mean. Create a box and whisker plot. This is also using 1 var stats. Again. Okay, 1 var stats. You arrow down. These are your 5 numbers. It's the same set of data. So it's going to be 34, 48, 65, 80, and 120. Okay, since I have to go from 34 to 120, I'm probably just going to count by tens here. Okay, so I'll start at 30, and then 40, 50, 60, 70, 80, 90, 100, 110, 120. Okay, 34 is my minimum, so that's where I'm going to put my dot. 48 is my Q1, so I'm going to eyeball that and just say there's 48 right there. Okay, median is 65. Median 65. Q3 is 80. And then max is 120. Okay, and then just create your box and whisker plot there. Okay, and that's 120 right there. Okay, so again, there's your min, there's your Q1, median, Q3, max. All right, so far so good? All right, we'll keep rolling here. Range. How do you find the range? Max minus min. Okay, which in this case is 120 minus 34.
86.
Thank you. 86. Okay, 86. And again, folks, if you want to write your little note to yourself here, max minus min for the range. That's not a bad idea. Okay? 50% of the data is below what number? Well, it's below the median. 50% of the data is below the median, which is 65. Okay? Interquartile range. What do we subtract for the interquartile range? Q3 minus Q1. Again, I encourage you to write this little note down for yourself, okay, so you can remember what you were actually subtracted there. So it'll be 80 minus 48. Okay, I just should be able to do it in my head. 32. What does the interquartile range indicate? Well, so range describes spread of the data. But since it's the interquartile range, it's not the entire spread of the data. It's only the spread of the middle 50%. So the spread of the middle 50%. Okay? Is the data skewed? Yes. Skewed right because of the outlier on the right. Okay? That outlier on the right is pulling our data, pulling our mean, the center of our data, it's pulling our data to the right there. It looks like it's moving more right than it really is, okay, because that outlier. So it's skewing things to the right. That outlier there skews things right. Shh. Okay? The right half of our data is more spread out, so it's skewed right. All right, questions on any of that? What's that? Okay. I will also scan this PDF as well, okay? So if that's, I'll scan it. So if you can check there, okay? Because I gotta keep rolling here. I want to make sure I get done, okay? So just I'll scan it and I'll make sure you guys can check it out. It'll be scanned, Brady, so you can check it out on the Google Classroom, okay? And I'll also be recording this too, so you can rewatch the video if you need to. All right, create a dot plot. Okay, so dot plots. Let's see here. The lowest data point I see is 12. The highest I see is 19. So 12, 13, 14, 15, 16, 17, 18, 19. I'm just going to count by ones. All right, how many 12s do I have? I see one. There's one. Okay, so one dot. 13s. How many 13s? Just one as well. Okay, how many 14s? 1, 2. Yep. Okay, 15s. 1, 2, 3, 4. Okay, 16s. 1, 2, 3. 17s. 2. And then 2 18s and a 19, yeah? Okay, remember, each dot in the dot plot represents a single piece of data. So there's 1 12, 1 13, so on and so forth, okay? 2 14s, 4 15s. What type of distribution is shown in this plot? Well, look at the shape. It's a bell, isn't it?
I said normal.
It's normal. Okay, like that. Normal. Okay. What is the mean of the data? Okay, so now I got to type it into my L1 and L2. Or sorry, type in L1 and then just get my, do one bar stats. So okay, stat calc. You said you got 15.6?
I did 625.
Yeah,
15.625. Yep, so I'm going to round it to 15.6. Standard deviation, you should have gotten 1.9 if you round it, or 1.89. I got 1.9 when I rounded it.
I did not round.
If you don't round, that's okay. If you don't round, that's okay. I'm going to round it, though, just for the sake of the brevity here. Again, what is standard deviation? That's SX. What does mean? That's X with a bar, right? Please make sure you know what those symbols are, right? SX and X bar for the mean and standard deviation there. Okay, if the data represents a large group of results, 68% of the results would fall in what range? For 68%, we do what?
You do it.
How many standard deviations?
You do 15.6 minus 1.9.
Okay, yeah, and 15.6 plus 1.9. So we're going to plus or minus 1 standard deviation, okay, from the mean. And then for the 95, we do mean plus or minus how many standard deviations? 2 standard deviations. Folks, I would suggest you write this down for yourself. Okay, I suggest you write that down so you don't forget it. Okay, all right, so the mean, let me just go ahead and type that in here. So it'll be 15.6 minus 1.9, 15.6 plus 1.9. So the answer is going to be 13.7 to 17.5. Well, yours because you rounded differently, I think. And that's okay if you rounded a little bit differently. And then 11.8 to 19.4. And again, if you round it a little bit differently, then your answers might be a little bit off. Okay? Okay. Yeah. So, all right, next we're talking about scatter. So any questions on standard deviation, anything like that? Okay? Again, folks, please, 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 if you have like tuned me out already, tune me back in. You guys need to be writing this stuff down, okay? I can't beg you enough. Please make sure you're writing this stuff down. It's going to help you to write this down. Mr. Wood, I'm never going to look at this again. You might. And so you really should write this down. You might wish that you had written some stuff down, okay? So please write some stuff down. All right, anyway, we got two scatter plots here, okay? What type of correlation is in this graph? Yeah, it seems like a strong positive, I would say. I like that you use the prefix the strong there too, or the description, the modifier for strong. Okay, I would say very strong positive. How about this one? I'd say weak negative. If you just say negative, that's okay. I'll go ahead and say weak negative, though, because it's definitely not as linear as this guy right here. Okay? It says to draw a line of best fit. To do a good line of best fit, what should we do? To do a good line of best fit, you want to draw your line where? Through the what? Yeah, through the center of the data, okay? Don't like zigzag them, though, a straight line. So just kind of like, eyeball a little bit, something like that. Okay? And then for this, same thing, but we're going to go down. So again, through the center of your data points there, something like that. Okay? So check, check. See, above there. Okay? We're going to skip 19 to 28. Okay? So don't worry about those. We are going to use we're going to find the linear regression equation here. So, okay, I got to type these in. Actually, let's see here. Anna, I know you did them, right? Yeah. Do you mind if I just use your numbers then, please? What's your linear regression you got for number 22? The equation, the equation, please, yes.
Y equals 1.23x plus 1.28.
Okay. And then how about for the number 29 there? Mm-hmm. 8.29. Thank you. Okay. And can you go ahead and give me your correlation coefficient for 23 and 30 as well, please?
I got
0.99. Okay. And 30? -0.94. Okay. Thank you. So, real quick here, folks. Do you guys remember how to come up with a linear regression equation? So, L1, L2, okay. Data in L1 and L2, okay, for your x and y coordinates, and then do stat, calc, lin, reg, ax plus b, okay? And again, if you got that down by heart, then don't feel like you need to write it down. But if you don't have it down by heart, you think you might forget, you should write down those calculator commands. Data goes in L1 and L2, stat, calc, lin, reg, ax plus b, okay? Okay, and that'll give you your linear regression equations and your R values for the correlation coefficient. Now, strong correlation coefficients are close to what numbers? Strong correlation coefficients are close to either
strong is 0.8 or over, right?
Or negative 0.8 or lower, we would say.
Is 0.5.
0.5, yeah, 0.5 or lower there too. Okay, so Jackson, what were you going to say? Strong, yeah, closest to 1. So the stronger you are, the closer you're going to be to 1, or if it's negative, the closer you'll be to -1. Okay? So which one of these is the stronger correlation? The 0.99, because it's closer to +1 than negative 0.94 is to -1. Okay? So 0.99 is stronger because it's closer to 1 than negative 0.94 is close to negative 1. Okay? If these were reversed, so if this was negative, what should I say here? If it was negative 0.99 and positive 0.94, then this one would be the stronger one. Okay? It's whichever one is closer to 1 or negative 1. Okay? That gives you the stronger one. All right, questions on any of that? All right, if not, then turn the page here. Okay, I think we're going to be able to make it, hopefully. Okay. Complete the two-way frequency table. So frequency table is just a straight up numbers. Okay? Two-way relative frequency table is going to be either a decimal or fraction or percent that you can give there. Oh, it says record your result as percents. Never mind. Forget that because it says percents. Okay? So give me the percents here. All right. So how do I figure out these cells right here? How do I figure out this cell right here? What do I need to do? 15, 6, and 1. Add them up, right? So 15 plus 6 plus 1, which equals 22. Okay? 12 plus 7 plus 9. Let's see, 19, so 28. 15 and 12, 27. 6 and 7, 13. 1 and 9, 10. Add these up. 13 and 27 is 40, plus 10 is 50. Whoa. Messed up that 50 there. Pretty good. Okay? Easy peasy filling that out. Now, here, how do I come up with the percents? What do I do now? So like for Coke, let's do boys Coke. 15 divided by 50, which gives me 0.3. What is that as a percent? 30%. Okay? And then let's see here. I'll just keep doing the rest of these. So 12 out of 50 is 0.24, so 24%. Okay? And then 0.54 here, which is 54%. I guess I should know these because it's going to be all double. This one's going to be 12%, 14%, 26%, 2%, 18%, 20%, 44%, 56%, and then 100%. Okay? Now, when we do these next questions, please read carefully. 32 asks for the joint relative frequency. Okay? Relative frequency. Am I using the top table or the bottom table? Bottom, because that's the relative frequency table. Okay? See, relative. Okay? Of students surveyed who are girls and prefer Coke. What percent of girls prefer, or sorry, what percent of people are girls that prefer Coke? Look at your table. 24%, right? Coke, girls, 24%. Okay? If there are a total of 150 students surveyed, how many would be girls who prefer Coke? So 24% is the percent of people who are girls that like Coke. If it's 150, we're going to do 0.24 times 150 here. The percent as a decimal times the number of students. Okay, 36 is the number of students. Okay, 24% are the girls that like Coke out of 150 students, so 0.24 times 150. Okay, what is the marginal frequency? Do you see relative frequency in here? It's not relative, so it's the top table. Marginal frequency of students surveyed who prefer Pepsi. Okay, how many students that surveyed preferred Pepsi? 13 out of 50, right? But we'll just say 13. I think we can just give the number 13 there. It's fine. Okay, what is the conditional relative frequency that a student surveyed prefers others given that the student was a boy? So again, we're only focusing on boys, okay? Student was a boy, focus on that. And again, it's relative frequency, so we're using the second table, okay, of the boys. Oh, actually, we'll just do it this way. Okay, so let's see. How many boys preferred other? One boy out of a total of 22. So 1 out of 22. One boy preferred other out of 22 total boys. Okay, again, we're only looking at the boys because it's given that the student was a boy. So we're going to forget all about the girl stuff. Okay, one boy out of 22. And so that is 0.045 repeating, which we'll say is then 4% or 4.5% if you like. Okay, I rounded that. Okay. All right. 36 says, give an example of correlation without causation. So what this means is that just because there is a correlation between two data points, you don't necessarily mean that one causes the other. Okay? So, for example here, I could say something like, I don't know, as age increases, gosh, I'm trying to think of something that wouldn't be related. Goodness gracious. As age increases, hair length increases. Okay? It's not necessarily that your age influences how long your hair is, right? It doesn't have to be correlated there. An example of correlation with causation, okay, as study time increases, test average increases, right? This one you would expect to have some sort of causation, right? The more you study, the more you expect your test averages to increase. Okay? Right. 38, well, you put all your study time in during class when you're working on the stuff that I gave you. 38, what would a correlation of 0.68 tell you about the relationship of exercise and energy levels? Okay, so first of all, it's a positive 0.68. It means a positive 0.68. So that would mean as exercise increases, what should happen to energy levels? It should also increase. So as exercise increases, okay, energy levels tend to increase. Okay? But it's going to be like I don't know, not a strong correlation. It's not strong, but we also wouldn't say it's weak necessarily either, right? I mean, I guess you could say it's weak, I don't know. Okay? But since it's positive, that means as one increases, the other increases. Or as one decreases, the other will decrease. So decrease exercise, decrease energy level. Increase exercise, increase energy level. That's the positive correlation. All right, one sec. And then negative correlation coefficient. Negative correlation, again, these are R values here. Okay? Negative correlation coefficient. What does that tell you about exercise and weight? So if it's a negative correlation, that means as one increases, the other decreases. So as exercise increases, okay, weight decreases. Okay? Or you could do it the other way. As exercise decreases, weight increases. Now that's actually false because, I mean, you got bodybuilders and they put on all sorts of mass even though they're exercising a whole bunch, right? Because they want to gain all that muscle mass. Muscle weighs more than fat does. Okay? So anyway, question Brady. So this will be our last test today, tomorrow, and of course then Friday for the Performance Matters. I don't anticipate any other assessments, no.
What are we going to do on the Tuesday?
I am not sure, but